Ian Pratt, I'm the CEO and co-founder of Bromium.
So how are you finding today's conference?
Well, it's been fun, it's been busy. We've been doing quite a challenge on our booth, which has been dragging, causing a lot of interest. We've been offering to, encouraging people to bring along all of the malware that they have been hit with over the last few days. Actually bring it along and run it on any of the machines on our booth. And we'll show that we can protect them from it. All of the malware that they bring along, and also show them exactly what it would have done, and that's generated a lot of interest. And if in the unlikely event that anyone was to compromise one of our machines, we'll give them £10,000. So that's certainly generated a lot of interest and traffic to the booth. It's been fun.
So what are the most problematic malware out there at the moment, would you say?
Well, I think the malware which a lot of is drawing a lot of noise, or creating a lot of noise right now, is the crypto ransomware. That's the malware where typically people get it on their machines by perhaps opening an email attachment or clicking on a link that they receive an email, or sometimes just being unlucky, researching something on the internet, going to a website, might be a reputable website like CNN.com or something like that, but one of the adverts on that website is malicious and delivers the crypto ransomware to their machine. It then encrypts all the files on their machine, pops up a ransom note, and demands payment to get the files back. And in an enterprise environment, if that machine's connected to a network share, it might encrypt all the files on the network share. And these malware attacks are, until CryptoLocker and these other ransomwares came out, usually what people were trying to do is to stealthily take over a machine and remain hidden, because they'd then use that machine for various purposes. It might be part of a botnet sending spam, or more nefariously, they might be using that as a launching pad to explore deeper into the enterprise and actually use that to take the information they're actually looking for, whether that's customer records, whether it's credit card numbers, or whether it's your intellectual property, if it's the top secret plans for the plane or whatever. That's what they would be using that compromised endpoint to do, and so they would be being stealthy about it. The big difference with this crypto malware is that it is announcing its presence. It pops up something on the user's screen asking them to pay a couple of $100s to get their files back. And that's why it's now getting people's attention. All of this stuff was happening before, but it was all stealthy. Now people are seeing that all of this stuff is getting through to their endpoint, and it's getting through to their endpoint even if they've invested very heavily in security. There are companies which we work with that have perhaps spent $100 million in boxes to put in the network and with software running on the endpoint, and they're still getting hit with CryptoLocker. And if they were getting hit with CryptoLocker, it certainly would mean that they're getting hit with all of the stealthy malware from nation states or other criminals that want to extract their IP or their credit card numbers, etc. And that's why they choose to work with us, because of the approach that we have that can really solve these problems. We're not relying on detection.
So what's the biggest challenge for you at the moment in your particular sphere of activity in the security industry?
So I think the challenge for the security industry is that the approach that has traditionally been used to try and stop malware is detection based. It's having a model of what is bad, and that might be a file hash, it might be a signature, regular expression, or it might be a behavior. And all of these products out here on the show floor, pretty much the way they work is looking for that pattern. When they spot that pattern, they try and block the execution of what it is that they've spotted. But the trouble is that we've known since the work of Alan Turing in 1937 that is a mathematically impossible problem. You can't build something which is going to look at a Word document or a web page and decide is it good or bad. So the best you can do is to come up with a set of heuristics, and you can generate those heuristics by hand, or you can use machine learning, but you're generating heuristics. And the trouble is that the attackers have huge advantages. They can get to take an attack they've created, make some small change to it, such that it no longer is detected by those heuristics, and then it will just sail through the network box, get given a clean bill of health on the by your software running on the endpoint, and of course it will then detonate, corrupt that machine, and whether it's ransomware or something nastier and more stealthy, it will create a problem for you. And the other advantage the attackers have is they only have to be successful once, whereas the defenders have to be successful every time. You know, they can flip one bit in their attack and send you a different one every hour, and you know, sooner or later that's going to get through. And so all of these detection-based technologies, you know, people have been trying to build better detectors for years. Machine learning and approaches like that have been used for years to try and build better detectors. And if you believe the vendors, they're getting quite good. They can get 97% detection. You know, some people here are even claiming 97.5%. I think if you went to speak to a CISO, they'd probably say it's more like 70%. But supposing you even gave them the benefit of the doubt, supposing it was 98%. Well, if you're an organization with 100,000 users and you're being hit with say 1,000 pieces of malware a day, even at 98%, a lot is going to be getting through. And actually you don't really know what that figure is, because you don't know what you don't know. You don't know the things that you're missing until it's too late. And also, the things that get through are the really nasty things. It's the things where someone has put some effort into evading the detection. Those are more likely to be the attacks that cause you real harm. Crypto locker, if it's just asking you for $200 to unlock the files on that machine, you know, it wasn't really targeted at you. They were going after anyone who would click on that link, and they may have compromised some user in an enterprise despite the 100 million that some of these financial institutions have invested in security. So if that can happen to them, just without someone even really trying, it's clear that all of the nation states and gangs with real criminal intent, not to take $200, but perhaps to encrypt some database within the organization and charge millions of dollars for it to be released, or more likely they'll be using that to the access that they have to perhaps do fraudulent wire transfers, or to just steal the intellectual property of a drug company or a petrochemical company. So those are the challenges that those organizations are facing. And crypto locker and ransomware just helps to highlight the problem. It just shows them how much stuff can easily get through their perimeter. And that's why they're needing to look for other approaches.
Yeah, you've touched on data protection there. I mean, obviously organisations like BCS, for example, huge amounts of data, and many other organisations start to move their data, personal information off to the cloud. I mean, what do you think the organisations like the NHS will have to do in future to safeguard our information?
Well, moving all of this information, is typically stored in databases, whether that's on-premise in servers in the organization, or whether it's in the cloud. I think there are definite security advantages for many organizations of moving to the cloud, because at least if you're working with an organization like an Amazon or a Google or a Microsoft, those are companies which understand security. They take it seriously and probably can do a better job than the vast majority of smaller organizations, and actually probably a better job than all but the elite enterprises. So moving stuff to the cloud can actually help from a security point of view. But at the end of the day, that data has always got to be accessed by some user from an endpoint, probably an endpoint running a desktop or laptop or tablet, probably running Windows or perhaps Mac, perhaps it's a Mac. And the point of entry for most attackers into an organization is actually those endpoint systems. If you do the analysis over the last 10 years or so, about 75% of the attacks have originated, which have resulted in breaches, have originated on the endpoint. So some user clicking on something, resulting in their machine being compromised, and that being effectively the entry point that enables the attacker to make off with the data. And if you look over the last few years, it's an even higher percentage than that, because as an industry, we're generally doing a better job of securing server infrastructure. It's actually a rather easier problem. If you think about it, servers, it's a far more static environment, there's a lot more change control around it, it's running typically a single application. It's far easier to secure, whereas on the endpoint, it's a very dynamic environment. You've got new web browsers, new plugins, continual updates for all of these components. You've got a lot more code running on the endpoint. And it's just crazy that, as I click on things, go browsing the web, it's pulling down code from all of these websites that I know nothing about, have no control over, and running it on my endpoint. It's just a much harder environment to secure. And so that's really where, as a company, we chose to focus our efforts trying to solve the hardest problem of how do we secure the endpoint. What we do is, it's a different way of trying to solve the problem. Rather than relying on detection, we provide protection through isolation. So, just to use an analogy to describe what we do, imagine that for every task you wanted to perform on your laptop, imagine that for every website you wanted to go to, you unwrap a brand new laptop, you take it out of its packaging. I'm going to use it just to go to that one website. And then when I click a link taking me to a different website, I'm going to put that laptop away, unwrap another laptop, use it just for that website. And similarly, supposing I download a document, I'm going to use this laptop for editing just that document. If I've got another document, it's on a different laptop. And what we're doing is providing that same level of isolation, or a similar level of isolation, but doing it with virtual machines. So if you think about it, if you were having a separate laptop for every task you performed, you wouldn't care whether that website was good or bad, or whether that Word document was malicious or not, because there's nothing else on that laptop. There's none of my other documents, so there's nothing to steal. We can arrange that it doesn't have access to my corporate network, so there's nowhere for it to go within the corporate environment. And it doesn't have to have my identity. It can be a guest user account, so it doesn't even know it's my laptop, and there's certainly none of my credentials or certificates there. So it's creating this new virtual environment, a new virtual machine. Pretty much every time you click, every time you're clicking on a link or opening a document, we're creating a new virtual machine, pristine environment, putting in just that particular document or allowing it to go to just that particular website. And then when I close that document or I click on a link to a different website, I'm going to throw that virtual machine away, unless I want to keep it for forensic purposes, and we'll talk more about that later. But we're always starting from a pristine state. And our goal is so that from a user experience point of view, it's completely unchanged. It should work just like a regular Windows machine or just like a regular Mac, but every activity is taking place in its own virtual machine. And at that point, I don't care about malware. I can go to a bad website. I can open a bad document, watch a bad, a movie which would corrupt my system, because it's only corrupting the virtual machine. It can compromise the application. It can compromise, you do a privilege escalation to compromise the operating system kernel. It can modify files on disk and perhaps change registry settings. It can install a rootkit. It really doesn't matter. It's having no impact on the underlying physical machine and no impact on any other task that I'm running. So my VM, which is at my Barclays banking website, is going to be completely unaffected by what's happening in this other website, which I happen to have visited, which is malicious.